Okay, we are now back in business. Sorry about that. This is now part 2 of today's. Your other mouse was jealous. I think so. All right, back to lecture. And we haven't run out of time. No, we've got plenty of time today. Pointers. All right. Actually, someone had a question, didn't they? And then, shoot, I left the room, so I lost track of chat. Did someone have a question that I didn't get to answer? If so, ask it again. Otherwise, I'll carry on. But I lost access to the chat because you leave and you come back and it's gone. I didn't mean to break things with my offer. Oh, okay. Well, yeah. All right. So yeah, these are entirely different things. It just so happens that they share the same symbol. But in star, it's a pointer, memory address of where the integer is, not an integer. And star foo means that we want the value at that memory address. But this is like when we declare it, we use this, and then whenever we want to dereference a variable like that, we use the dereference. Well, what the pointer points to, yeah. So now a lot of people in the lab got hung up on this one yesterday, and it's because we didn't go through this example, but we got it all figured out. So some no pointers. If I write this code, a equals 1, b equals 2, c equals 0, and call some no pointers a, b, and c, I go here, say x, this function here takes x, y, z. So it's got these parameters x, y, z, which of course when we call we'll have the values of whatever a, b, and c are. So 1, 2, and 0. So x is 1, 2, or y is 2, and z is 0. And then I say z equals x plus y. So suddenly z becomes 3, right? Because x, like 1 and 2 is 3. So z becomes 3. But c and z are two different things. There is a chunk in RAM for our main that had, oh my gosh, this is so annoying. This is now coming back to curse me, like it's haunting me. Here's C, here's A, and here's B. Okay, oh my god. And I have 1, 2, and 0 inside of them. But then when I call this function up here, this one, it creates 3 new variables. 1, 2, 3. This one's x, this one's y, and this one's z. And then in here, x gets a copy of what's in A. Okay, what's in A? Well, that's 1. Y gets a copy of what's in B. Remember, this is supposed to be a B. This gets 2. And then C gets a copy of, or pardon me, Z gets a copy of what's in C, which is 0. And then down here I say, okay, now Z is equal to x plus y. Well, what's x plus y? Well, that's 1 and 2. So the inside of Z now becomes, I guess, 3. What is void? One moment. I will say that in 1 second. So in this situation, this variable Z now has the contents of 3. But you'll see that the variable C is left alone. The contents of C was never changed because Z has a copy of the contents of whatever C is. And the contents of C was 0. And then when this function finishes, these variables that were like assigned, they disappear. The computer goes, okay, I don't need them, they're gone, done. So this Z, although we just assigned it, we didn't do anything with it. Now, for the person that asked, doesn't return any type of variable. Absolutely. So yeah, Michael was right. So so this function main returns an int, I guess. If I were to write here, actually, here, I'll go to this example next, actually. So here, this function has a return. And the function, when you put this type right here in front of the function, that specifies what the return type is. So because Z is an integer, because that's what we said it would be here, Z is an integer because there it is. So Z is an integer, and this function needs to know that it's returning an integer. If I didn't put int here, C++ is going to say, hey, what? No. If I said like string, C++ is going, no, Z's an int. You can't do that. So these types have to line up. Again, another consequence of the strongly typed language. I heard another boop, I think. Basically means run with no return. Yes. So if we go back here, you'll see that this function here doesn't return anything. There's no return statement. So this thing it's not returning anything of any type. So void is a way to tell the function like, and the type of thing you're returning is literally nothing. Okay, thanks. Yeah, cool. You're going to be, this will become second nature very soon. So when we had this example, right, we made copies of the variables, we assigned them, and then, you know, they got left alone. Now, let's see what happens here. So in this case, I'll go back to my red pen, or I'll try to go back to my red pen. Why won't it let me? Okay, red. I have a box for A, a box for B, and a box for C. So we have A, B, and C. And then inside I have 1, 2, and 0. Then up here, I have something very different than what I had before. I had 3 boxes that were referenced, or pardon, I shouldn't say referenced, that use the names X, Y, and Z, but you'll notice that they're not integers. The things inside this boxes are going to be pointers to integers. And you'll see here, I'm actually taking the address of A, B, and C. So when the value I'm giving this here is not 1, 2, and 0. I'm giving it wherever in RAM A is, wherever in RAM B is, and wherever in RAM C is. So inside these, it's like, okay, this is this, this is this, and this is this. And then inside here, I'm saying, okay, go inside and get the contents of X. Okay, that's 1. Go inside and get the contents of Y. Okay, that's 2. And then go to Z, and inside of it, put the sum of these 2 things. Well, that's 3. So this now becomes 3. This function then finishes. These all disappear. But look, we now actually have modified these variables that actually weren't in this function. Isn't that interesting? I think so, at least. Any questions about that? Because it is a weird thing to do, but at the same time, it's actually not a weird thing to do, because if you're using lists in Python, this is what happened every single time you used a list. Is you never made a copy of that list unless you went out of your way to actually make a new list that was a copy of that list. Whenever you passed a list as a parameter, it copied the contents. Imagine A was a list, for example. When I would pass the list to the variable, I was never actually passing the list to, when I was passing the list to a function, I was never actually passing a list to a function. I was passing a pointer to where a list exists in RAM. So it's the exact same thing as with Python. It's just with C++, we now have the freedom of choice of, do I want to pass an integer, or do I want to pass a pointer to an integer? Now in Python, whenever you pass an integer to a function, it acted as if you were just making a copy of that thing. It acted this way. Which, okay, primitive types are going to act that way. But we have the freedom to choose. In C++, it gives us that flexibility. Okay, so for this one, it would actually change what's inside C instead of creating a separate Z value. So it creates a separate variable called Z. So so he's right, but Z is another variable, but the contents of Z is not like the integers. It's just a pointer that gets us to the chunk of RAM that is C that we actually wanted to modify. So you're right, it's, we didn't actually, that actually changed the contents of C. And the actual value of Z it wasn't stored in the variables that were created in that function. It was stored in the thing that those variables pointed to get ultra specific. Okie dokie. Oh yeah, I can't. Okay, yeah, so you put your hand. What's up? Okay, so you put your hand up. What's up? It's pick your poison. It doesn't matter. All I'm doing is showing that you can do this. And there are going to be times where you're going to want to do this. And there are going to be times where you very much don't want to do this. But these are going to come up once we're dealing with more complex objects, and not so much when we're playing around with integers and whatnot. I'm just showing you what you can do. But again, this is a bit of an example of look what you can do. And Well, in practice, why would I choose one over the other? Yeah, you wouldn't. You'd flip a coin maybe and pick whatever that one is. Not 99 times out of 100, I'm going to do it this way. This is the way I'm going to do it. 99 times out of 100, this is how I'll do it. Because this is just more like, when you do it this way, in a mathematical sense, so to take a step back, if it wasn't obvious already, our computer science, it's math. We just trick you into doing math. It's not calculus, but it's a different type of math. And mathematically, like, functions are functions. But this function has what we call side effects, which you might remember me talking about at the end of last semester, or I guess it was like about mid last semester. And that's like when we used a list. And the function modified the contents of the list, but the lists were like somewhere else in RAM. So this function here has side effects. It changes chunks of RAM that like aren't controlled by this function. Where this right here, this is a little bit more pure. In fact, that like this is a pure function. That's what it's like called mathematically. Because this function, you know, like it takes these values, it changes the values, and then it returns like this result, and it only does what it's like it has access to. One option is not better than the other. Anything you do with side effects, you can do without side effects, and vice versa. It's just, you can do it this way. This is basically how I would do it though, because I'm just comfortable doing it this way. Most other programming languages, this is how you're gonna do it. But anyways, this here is another way to achieve the same thing. You create the three variables, but then you return it. But I'm gonna still draw kind of how the variables, if I could have access to the pen, how the variables work. So down here, I've got A, B, and C again. And the reason I'm showing this again, if you find it's a little like over the top, me explaining it, sorry about that, but it's probably good to see kind of like physically what's the difference? Like what is actually different about this in the back? Like what is the computer actually doing that's different? So here I've got 1, 2, and 0. And then up here, I've got 3 new boxes. That's a box, trust me. X, Y, and Z. And I make a copy of A, so we put a 1 in here, a 2 in there, and a 0 in there. And then suddenly we put Z, the sum of these two. Oh, okay, so this becomes 3. But we say, okay, return Z. So this value here, the value of Z, which is 3, I don't know, I'm gonna put it here because this function returns it. 3, this function's returning it. These variables, they go away, they disappear because the function's done. But you'll see here, down here, I don't know, I'll do a different color if it'll let me. Down here, we've got the 3 that's being returned by this function. So the function's like going back to main and being like, I'm done, and here's what I'm coming back with. So all of this gets evaluated to the value 3. So what goes in C now? Well, I'm saying C, oh, you now have 3. Okay, so 3. There. So this is just another way of doing what we did on the previous slide. And I prefer it this way, but they're doing the same thing ultimately in entirely different ways. Maybe I'll reword that. They achieve the same outcome, but in entirely different ways. Yeah, okay. Ooh. So we can pretty much just use whichever will make more sense, easier to follow the logic, depending on the situation, and just adjust the necessary, to decide that we want to change, keep the same. Absolutely. And chances are, again, would there be a reason to, in the case, to assign a value to C before the function? Honestly, not really, but at the same time, like in many programming languages, when you create like a variable of type integer, it gets initialized to have a certain value. Like by default, it'll have the value 0. In C++, they don't have default values. It'll be whatever's in that RAM. Let me show you an example of that. Maybe I should have loaded this up. Okay, it's not taking too long. I'll show you an example of this. So the reason I assigned it to 0 at the start, you're right, it wasn't really necessary in this situation, but it is convention and good practice to assign it to 0. And this will make it in line with what we would expect many other programming languages, like the way they would act as well. But I'm going to say int ASD and not assign it anything, and then std cout ASD and Control Shift B. It might even give me a warning about uninitialized variable or something. It always takes a second to build the first time, despite how simple the project is. What? Uninitialized local variable is used. What? Is this? This shouldn't actually be an error. We're allowed to have default values. Maybe a new version of C++ doesn't actually let you do this anymore. Well, here, I'm going to do it a slightly different way then. I'm going to just ignore me for a second. Okay, there we go. Just pretend you're not seeing anything new. Okay. Okay, negative 1, 2, 3, 1, 2, 3, 1, 2, 3. 8,400, wait, negative 842,150,451. So all I did right here is I created an array, an integer array of size 5, and I said, okay, what's an index 0? By default, like in other languages, you create an array, it's going to have a default value of 0. In C++, no. In fact, I'm going to rerun this, and we'll see what happens. Is that the same number? Maybe I'm just getting that special value. 451. I guess maybe this is a special value in C++. Maybe it's that like OXCC, CCC, whatever. Long story short, let's see what happens if I run it a slightly different way. Yeah, it's doing the whole debug thing now. One sec. Okay, yeah, I guess it's a special value or something, but like it's garbage. It's not a special value. So that was a long-winded and slightly broken answer to your question of other programming languages. When you create a variable, by default, it'll have a default value assigned to it. C++, no. You don't get a default value, and you'll just have like, the computer's gonna go and be like, oh, okay, you want a variable called ASD, here's a chunk of RAM. Great, here you go. And then if you ask like, well, what's inside that RAM before putting anything in it? Well, the computer will just tell you what the 0s and 1s are inside that chunk of RAM. But again, in our situation, I mean, we wrote the code. We know that, you know, we were immediately going to change it and assign it a value. Okay, yeah, you're right. I guess we didn't need to initialize it, but I did it anyways for good practice. Now in this example, I'm showing you something funny. In fact, I'm going to, exit out of this, discard, and copy this code to show you something really strange. Build it. So here we go. I'm creating I've got my main, int A is 1, B is 2, C is 0. And then I'm passing the addresses of A, B, and C into the function called ruin everything, which of course takes 1, 2, 3 integer pointers. I should expect that because, well, 1, they're declared as integer pointers, and 2, well, I'm actually passing the memory addresses of A, B, and C, which are integers. And then what am I doing? I'm saying, oh, okay, make an int called, take the integer A and put that into whatever can points to. Now take B and put it into whatever B points to, and then take C and put it into whatever risky points to, and then print out ABC. I'm guessing you're looking at this code and you're thinking, what the hell is he? This doesn't make any sense. Actually, do me a favor, raise your hand in the chat if you're thinking, no, don't, what, why? Because that should be your reaction in this scenario. I want to see everyone's hand go up. There you go. Exactly. That's what I thought. Everyone is, everyone's like, yeah, this seems ridiculous. Well, let's see what happens when I run it. Oh yeah, 97, 98, 99. Yeah, that's fine. That makes perfect sense. Right? Computer's like, yeah, cool. Everyone who was in lab yesterday is going to know what's going on because we talked about this a little bit in the lab yesterday. But the funny thing is, oh, I hear a boop. Or is that those just hands going down or something? Okay. The funny thing is, this does make perfect sense, and here's why. So, when we encode information into a computer, it's just zeros and ones. And I'm not saying that as like ooh, it's all zeros and ones, man. No, like it's literally low voltages and high voltages that are flowing through your processor. And these zeros and ones mean like an integer, right? So if I see like whatever 99 is, which I think is 0, 1, 0, 0, 0, 1, 1. I'm missing something in there, but whatever the value 99 is in binary. In fact, here, let's find that out. Okay, it's because it's only 7 digits and I like to talk in bytes. The number 99 in binary is 0110011. That means 99 in binary if we are decoding those zeros and ones as an integer. Those zeros and ones, that binary string means 99 only if we are decoding that sequence of zeros and ones to be an integer. If instead the computer is like, no, I'm decoding these zeros and ones not to mean an integer. I'm decoding them to mean a character. I'm decoding these to mean a letter. Well, it just so happens that the character A and the number 97 have the exact same sequence of zeros and ones that mean the exact same thing. It just depends on how we decode it. So the encoding of 011000011 means 97 if we expect it to be an integer, but it means A if you expect it to be a character. So the encoding means different things depending on how we decode it. The int A is a string, right? Just being shown as an integer. Actually, so it's actually a character. And there is a difference between characters and strings in like C++ and many other programming languages. So if I wanted it to be a string, I would do this. You need the double quotes. Oop. But single quotes means only one single character. And one single character is like a nice type. It's like a primitive type. Strings, well, those can be like arbitrarily long, right? Like hello and gobbledygook are two different strings that have different lengths, you know? So how much RAM do we need to store that information? Well, it depends. How long is the string? When you only have a single character, well, I know how much room a single character takes up. You know, I don't need that much information to hold a character. So yeah, A is a single character, and a string would be a string of characters. That's why, you know, we call it a string. But let's see what happens if we do this with strings. Holy moly, we get something entirely different. What is going on there? So I guess this is going to act differently when we don't use characters, but we use strings. So that's funny. So the string will have a higher value since it's more memory taken up. That's actually not quite why. It has a little bit more to do. It has a lot to do with having more memory to be taken up. And it also, you are right. You're right that it has to do with more memory being taken up. but it also has to do with like, well, how the zeros and ones in that more memory is being decoded. So you are right. It has a lot to do with taking up more RAM. You're absolutely right. Let's see what happens. We'll end on this funny little weird thing that I'm going to do. I guess it's, yeah, I guess it's interesting how the length seems to, weird. What happens if I do? Uh-oh. Oh, it's because it's already, let me do it again. If you ever see that error, sometimes you just need to like, make sure you've closed the console or just try to rebuild it if you closed it the wrong way. So it's interesting how like the length of the string kind of, you know, the numbers, I don't know. Funny, isn't it? It's always kind of fun to play around, especially in C++, because it does give you the freedom to play around a lot. But anyways, hopefully you learned a lot. I'll see you next Tuesday or in lab today if you are in lab today. Otherwise, have a great rest of your day. Have a great weekend. And of course, you'll all be watching the Bills win on Sunday. So anyways, see you later and goodbye.